All right, folks, last time we used SOHCAHTOA to solve for a missing side of a right triangle when we were only given one side and an acute angle. Today we're going to be using SOHCAHTOA again, but this time we're going to focus on solving for an angle when the only thing we know is that it is a right triangle. Okay, so for 1 through 6, all we're going to do by starting out here is just a little bit of review for our ratios. Okay, so it's saying the sine of angle A. Remember, we always have to focus on one of our acute angles. In our picture, that's A for this one. And we're asked to find the sine, the cosine, and the tangent ratio of each of these. Remember that SOHCAHTOA helps us remember what sides go with each ratio. First up with sine, that is opposite O over hypotenuse H. So in our triangle here, across from angle A is the number 4, and our hypotenuse is always across from the right angle. That never changes, so feel free to go ahead and label that. So we've got opposite 4 over hypotenuse 5. So our sine of angle A is 4 fifths. We always want to reduce if we can. In this case, we cannot reduce 4 over 5. Next up, cosine, that's A and H, or the adjacent side over the hypotenuse. Going back to our triangle, the adjacent side here, the one that touches it but not the hypotenuse, is 3. So 3 up top. Hypotenuse, again, stays 5. So we've got 3 fifths for cosine. Last up is tangent. That's the TOA, or O over A. Opposite side in this triangle is 4. The adjacent side in this triangle for angle A is 3. Okay, so those are our 3 trig ratios for angle A. The next thing we want to do is the same 3 ratios, but this time focusing on angle B. I want you to pause the video and take care of those 3 for me, please. All right, over here, opposite is across, adjacent is next to it. Okay, so our sine is 3 fifths, cosine 4 fifths, and the tangent that switches to 3/4. Now what we're going to do is actually solve for the angles. What you'll notice here, we've got sine of A equals 4 fifths. That's actually an equation. A here is our unknown, so that we can think of kind of like an x. Okay, so what we want to do here, to solve for angle A, we're just going to look at this first equation to start out with. So sine A equals 4 fifths. Now we want A by itself, which means we have to get rid of sine. The problem here is sine must go with an angle. If you type in your calculator sine, it opens up a parenthesis there because it's tied together with an angle. Okay, so we need to think about for a minute how we solve equations. Okay, so something like x plus 2 equals 4. Okay, that's something we're familiar with solving for x. We subtract 2 from each side because this plus and minus are inverse operations, which means they cancel out. Well, 4 minus 2 we can easily do without a calculator to get x equals 2. Okay, very similarly, we can say for like 3x equals 512. Okay, this is 3 times x, so we divide by 3. Now on this side, it may not be as easy to solve without a calculator, so we type it in. Okay, we just take our 512 divided by 3, giving us our 170.6, repeating, for our x. Okay, but the key is, over here on the left-hand side, the inverse operations cancel each other out. The same thing is going to work for this equation here. By definition, the inverse operation of sine is the inverse sine. Okay, you'll notice on your calculator right above the sine there's this weird looking thing that says sine with a -1 exponent. That is the inverse sine. Okay, so inverse sine is just sine with a -1. Same thing goes with inverse cosine and inverse tangent. Okay, they cancel out the sign. They get rid of it. Okay, so here's how we write it. What we do to one side, it's really important that we do with the other, just like with our x plus 2 equals 4. We had to subtract 2 from both sides. Okay, same thing over here. We're going to take the inverse of both sides. But because when we type in sign, it opens a parenthesis, that's how it works with the inverse too. Okay, so this whole thing is going to go inside of that parenthesis. Same thing on the other side. We'll say the inverse sign of the 4/5. Over here, those cancel just like our plus 2 and our minus 2 cancel, and we're left with our a equals the inverse sign of 4/5. Now, just like with our 512, it may not be obvious what the answer is here. That's where our calculator comes into play. We hit second or shift, then sign, and type in just that 4/5. So now it's 53.1. We're solving for A. Remember, in our triangle, A is an angle, so that's 53.1 degrees. Now, just to show you, since we had 3 separate equations that had A in there, we could actually use either of those other ones as well to solve for the same A. Okay, just like with the regular sign, to get rid of the regular cosine, we use the inverse cosine on both sides. Okay, remember with the sine, cosine, and tangent, we put parentheses around those things. Over here, we cancel, and we're left with A equals the inverse cosine of 3/5. When we type that in our calculator over here, we get the same number as before. And that's important because we're dealing with the same A value for the same triangle. They have to be the same. Last one, tangent A equals 4/3. To get rid of tangent, we use the inverse tangent. Okay, use that -1 exponent. On both sides. So we're left with, when these cancel, A equals the inverse tangent of 4/3. Oops. Inverse tangent. Get that shift on there. And 53.1 degrees again. Okay, so all 3 of those gave us the same answer. Because of that, if we're given all 3 ratios, or we have all 3 sides on the triangle, it does not matter which trig ratio we use, sine, cosine, or tangent, to set up our equation. They all will give us the same answer. Okay, for that reason, I want you to use one of these 3 equations to solve for angle B. Pause the video and get that done. Alright, so you can check your work here. You've got 36.9 degrees, and that could be using sine, cosine, or tangent, the inverse of any of those. They all come up with the same value. Now, what I want you to pay attention here to is our 2 angles, the special relationship between those in our triangle here. We know that the 3 angles in a triangle should equal 180 degrees. Well, when you take out 90 degrees of it, you should be left with 90 degrees between the 2 acute angles. If we go over here and use our 53.1 plus our 36.9, you'll notice they add up to 90 degrees. For that reason, when we're solving for both angles in the triangle, we're only going to solve for one of them, and then we'll subtract from 90 degrees to find the other one. Okay, so starting out with number 9 here, we're always going to focus on solving for x first. So I want you to mark that angle, and then we're only going to mark the sides that are labeled. Okay, last time our sides, one of them was an x. In this case, they are both numbers. This 8 here, we've got the opposite side, and then we've got the adjacent side. Remember, so, ka, toa. Okay, so here we've got O and A. That's toa for tangent. tangent of our angle. In this case, our angle that we marked is a variable x, and then we're setting that equal to opposite over adjacent, or 8 over 10. Now normally when we set up these equations, it was important that we reduce this number, 8 over 10. Because we're not done yet, we still have to solve for x. It's not super important that you reduce that answer because it's not our final answer. Okay? Our final answer, we need to get x out of there, and that means we have to get rid of this tangent here. Remember, to get rid of tangent, we use the inverse tangent, that -1, on both sides. On this side, they cancel, and we're left just with the inverse tangent of 8 over 10. And that's something we get to type in our calculator. Shift and then tangent, 8 divided by 10. So our first angle is 38.7 degrees. And remember, if our two angles add up to 90, we can take 90 minus that number to get our second one. So now we'll take 90 minus that 38.7. And our second angle is 51.3 degrees. All right, let's try another one. Over here, again, first thing we do is mark the angle x, and then mark the sides that are labeled for us. We've got the opposite, which is 20 across, and then 25 is across from our 90 degrees, so that makes it the hypotenuse. Okay, we have O and H, that goes with the SO, which means sine is our trig function. Okay, sine of our angle, which is x, equals, our ratio goes opposite over hypotenuse, so 20 over 25. And then we have to get rid of this sine by using the inverse sign on both sides. On the left-hand side, they cancel, leaving just that x. And then we've got the inverse sine of 20 over 25 on the right. Giving us 53.1 degrees for our first answer. Second answer, we just have to take that and subtract it from 90 degrees. And we come up with 36.9. All right, on number 11, our x is the angle of focus here, 20 is our adjacent, and 25 is our hypotenuse across from the 90 degrees in our picture here. Okay, so we are using CAH in SOHCAHTOA. C stands for cosine, so we've got cosine of our angle x equals, adjacent is on top, so 20 up top, over hypotenuse, 25. And to get rid of that cosine, so that x is by itself, we have to take the inverse cosine. On the left, they cancel, and x is the inverse cosine, 20 over 25. We get 36.9. And then we've got 90 minus that 36.9 to give us 53.1 degrees. Now, you'll notice these numbers here are a little bit familiar. This is the third time we've seen a combination of these two. That's because all of those triangles with the same angles here are similar triangles. Okay, similar triangles have to reduce to the same ratio of sides, but their angles always match up. So all of these angles that have been coming out to the 36.9 and 53.1, they're 3, 4, 5 triangles that have just been scaled by some factor. Okay, so don't feel bad if you see the same angles appear over and over again. They show up often when you're dealing with those Pythagorean triples. All right, number 12, you'll see it's a little bit different than the ones we've been doing because there are 3 sides here given. What that means is we have 3 options. Okay, just like with our first example, when you have all 3 sides, you can use sine, cosine, or tangent. Okay, so here we've got our opposite being 8, hypotenuse across from the 90 is 10, and our adjacent is the 6. So we could say that sine of the angle x is equal to opposite over hypotenuse, 8 over 10. We could say that cosine of x is equal to 6 over 10, or we could say tangent of x is equal to our opposite over our adjacent, or our 8 over 6. Okay, all of these are going to work. Remember, we're taking the inverse on each of these, so just to show you, inverse sine, 8 over 10, inverse cosine, 6 over 10. Oops. Good. And inverse tangent of 8 over 6. I'll retype in the first one so you can see it on the same screen here. But all of them give you 53.1. Okay, so it does not matter which one you use. All right. Then to solve for the other one, 90 minus that 53.1, and that gives us 36.9. Once again, we're seeing those same numbers because this is a 3, 4, 5 that's been doubled. All right. I want you to take this time to pause the video and try number 13 and 14. Both of these triangles ended up being cosine because we had the adjacent and the hypotenuse for the sides that we were given here. Okay, you'll notice on both of these I kind of skipped a step where you take the inverse on both sides. For the same reason, when we say x plus 2 equals 4, sometimes we can just subtract that over on our head immediately and just say, well, that's going to be 4 minus 2, which is 2. Okay, so you can skip that step if you feel comfortable. Okay, but I do want to see you write the equation and then write what you typed into your calculator. Okay. All right, next up, I want to talk about this example because, again, we have 3 sides given to us. You'll notice one of them is a decimal. If I ever see that, usually that's the one I get rid of to tell me which one to use, sine, cosine, and tangent. And it's not that you can't use a decimal. Oftentimes you will have decimals in your ratio of your sides, and that's okay. But if any numbers look nicer, I'll use those numbers. Okay, so here, in this case, we would have opposite and adjacent, and so that would tell me to use tangent. Okay, so tangent of the angle x equals 18 over 12. To get rid of this, we're using the inverse tangent on both sides. And we're left with x equals the inverse tangent of that 18 over 12. Okay, so inverse tangent, 18 divided by 12 is about 56.3 degrees. And it doesn't ask us to solve for the other angle. Okay? Go ahead, pause the video, and pick any trig ratio on the next one to solve for that angle for me. Remember, no matter which one you choose for these 3, you should come up with the same answer. And that answer here is 46.4 degrees. Now, just for a heads up, next time we are going to be solving for both sides and angles. You'll notice every single time here we had to use the inverse. That's because our x was on the inside of the triangle. When you're solving for an angle, the x, the unknown, is on the inside. We'll always use the inverse. When we're solving for a side using SOHCAHTOA, that's when we use the regular sine, cosine, tangent. Okay, a couple word problems to finish up here. It says a water slide is 20 foot tall and 35 foot long. Okay, so what is the angle of inclination of the water slide? Okay, so our first job is just to draw a slide here. We've got a slide, usually stairs up to the top, and then a slide going down from there. Okay, so you can see our right triangle formed. Says it's 20 foot tall. Tall is always going up and down for the height. So that's our 20 foot over here. And then it says the slide itself is 35. So that's where you would actually be sliding on this thing. Okay, so that's our hypotenuse. Now it wants the angle of inclination. That's an angle up. Incline means to go up. And then it's always from a horizontal segment. So in our picture here, the horizontal segment goes here. The angle up from there is down at the bottom versus up here. Okay. In general, when we're talking about angles, it's always going to be the one that's with the horizontal segment of the triangle. All right, so to solve for this, just like last time, we need to label our sides we're given. So we've got this 20 being the opposite across from it, and this 35 we said was the hypotenuse. So O and H goes with S for sine. To set it up, it'll look like sine of our angle, which is X, equals opposite on top, so 20, hypotenuse on bottom, 35. And then we need to take the inverse on both sides to solve for that angle. So we'll type in the inverse sine of 20 divided by 35. And that gives us an angle of about 34.8 degrees, which seems reasonable for a slide. Okay, usually if we too high, that would be really scary, or too low wouldn't be very exciting for a water slide. Okay. Next one, it says an airplane is flying at an altitude, this word means height, of 20,000 feet and is 264,000 feet from the airport runway. Okay, at what angle would the plane need to descend to land on the runway? Okay, so I'm going to start out by just drawing a plane here. And it says this plane is 20,000 feet high. Okay, so we need to draw a ground because this time our plane is in the air, and specifically it's 20,000 feet in the air. So from the ground up, we've got 20,000 feet. All right. Then it says it's 264,000 feet away from the airport runway. Okay, so here's our airport, but we've got this runway that we want to land on. So that's really the distance that we're going. And it says this distance on the ground, this distance away, is 264,000 feet. Now, it's important when you're doing these problems, when it's measuring distance, we're measuring it on the ground, not diagonally, because when you're talking about a town being so far away or a plane having to fly this many miles or this many feet, has to be at ground distance, horizontal distance. Okay? But now you'll see that we have this right angle formed. We can go ahead and connect our plane to the runway where we're going to hit because there is our right triangle. Now it says, what angle would the plane need to descend to land on the runway? Okay, well the word descend means an angle down, but again we talked about it always has to be with a horizontal segment. Okay, well here it looks like it's going down, but that is not horizontal. So if we're talking about the angle of descent, really where it is right here. Okay, but this triangle doesn't exist. We've got this triangle here, and this triangle is equal to the one at the bottom. Okay, so again, just remember, when you're solving for an angle, you want to look for the horizontal piece in your triangle. Okay, so our angle here, angle of descent, sometimes this thing is called a glide angle. Okay, has to be with a horizontal piece. All right, so now that we have that x down that we're solving for, we need to label our sides. So we've got opposite and adjacent here. O and A tells us tangent. So tangent of the angle x equals 20,000 opposite and 264,000 adjacent. And we'll use the inverse once again to solve for that angle. If you want to cut off some of those extra zeros, you are free to. Okay, but remember, we do not have to reduce to be able to solve these problems. Okay, so we've got about 4.3 is our angle of descent, or our angle that our plane is pointing downwards. If we were to solve this problem with this angle up here, okay, remember that these have to add up to 90 degrees, we would have gotten an answer for 85.7. And if we think about a plane trying to take an 85-degree turn downwards, okay, that'd be really scary. Too fast of a descent there. Okay, so expect your problem on airplanes to really be under around 20 degrees here. It has to be a slow angle to get in there safely. Okay. If you have any questions while you're doing the homework, please come see me.